Good morning, class. This is my first recorded lesson. This lesson is going to be about work and energy. This is practice towards our eventual flipped classroom, so I hope it works out okay. You have to bear with me with the technology because it's new for me. So today we're going to talk about work and energy. Now, those are words you know about, but in physics, almost all the words have very specific meanings that are not necessarily the same as the meanings in regular speech. So, for instance, let me just minimize that. For instance, when we talk about work, you have schoolwork. You can do all kinds of work. For instance, if you were holding a very, very heavy bag, even if you weren't moving, you would be thinking that you're doing a lot of work. In physics, you wouldn't be doing any work at all, because in physics, work is only related to moving things. And basically, work is all about if you have a force. Okay, let's see. So let me just play around a little bit here. All right, so I'm going to make a line like this. Okay. So, nope, not dotted. All right, there's a force. Turns out that in physics, a force directed in the same direction as a motion is the only kind of force that does work. So if you have something moving to the right, but you have a force going downward, that force going downward is not doing any work. The only force that's doing work is the force that's in the same direction as the actual motion. So let's see, what if we draw a shape? Okay, so let's have some shapes here. That looks like shapes. Okay, we want to make a square. Okay, so we've got this square, okay, and it's sitting on the ground. All right, so we'll get a different line, and we're going to make it just that kind of line. Okay, we're going to draw it right across here. There's the ground, okay? So now, if we take our force, push it like this, we're going to have that block there move to the right, and that force is going to be doing work on that block. And it turns out that the work it's going to be doing is just the force multiplied by the distance. Okay, so we write that like this. Okay, work equals force times, we use S sometimes for distance in physics, okay? So the work equals the force times the distance. So I could tell you that that's the whole deal, but it turns out it's a little more complicated than that, of course. But that's a start. So for instance, let's say that we travel a distance of, we don't have a double arrow. That's crazy. Well, let's use this one. Okay, so we travel a distance of, say, oh, that's not a line. Whoops, sorry. Didn't mean to do that. Undo that, okay? Okay, so let me make a line. All right. Still no double line. Okay, we'll just use this one. Okay, so we're going to travel a distance, say, of 10 meters. Okay, and let's say we're going to be pushing with 30 newtons. that means that work is going to equal 30 times 10 equals 300 joules. Okay? That's supposed to be times. Let's see, what can I do here? Isn't that interesting? Try that again. Work equals 30 times 10 equals 300 joules. Not so bad. Okay, so anyway, I should fix that because one of the things is that you need to be taking notes. I'm going to be checking for notes, and that's going to count towards your homework. So you're going to want to make sure you take notes. I'll tell you when there's really important things to take notes on. There we go. Okay. So let me just get rid of some of this junk. Alrighty. So there's our whole situation. So that's one story. Now, why don't you write that down. If you need, you could always pause the video and copy that down, because now I'm going to make some changes, okay? So now we're going to make a slightly different version of the same story. Okay, so I'm going to grab this right here, and let's see if I can, whoops, that's not what I wanted to do. I want to rotate it. Aha. So let's just say that it looked more like this. And let's just say that the angle in here was good old 30 degrees. Okay? So now we've got 30 newtons pushing down at 30 degrees. Well, as you know very well, there's really two components to that force, right? Okay, so let's grab a line, and let's make that line red. Let's make it thinner, and we'll use this arrow. Okay, so what we've got is we've got a component going to the right, and we've got a component coming down. So this is the X component of the force, and this is the Y component of the force. Now, the Y component of the force is not doing any work. It's not moving the mass at all. Only the X component is moving the mass. So we need to express this. So what we're going to do is we're going to replace this expression right here for work with a slightly different one. Okay, this is a new one. Work equals F cosine theta times S. Let's see if it can handle that. Very nice. Okay, so we're going to get rid of this one. All right. Oh, we're losing connectivity here. There we go. What the heck? Why have we got, battery. Is that it? Pen battery. Okay. We're going to have to stop now and recharge the pen. Okay. Where's our recording thing? There we go. Okay, we're back. I've got a different microphone and the pen seems to be charged. So let's continue. Let's make a fresh page. All right, so Next thing we're going to do is we're going to do example 1. All right, let me just get used to this thing again. Okay. Where's our page? Okay. Just a second. Okay, so example 1, page 161. So if you haven't gotten your book out yet, what you can do is you can pause this video and go get your book and open it to page 161, and you can read along with me. Okay, so we're looking at example 1. Find the work done by a 45 Newton force in pulling the suitcase in figure 6.2a at an angle of 50 degrees for a distance of 7.275 meters. Okay, so let's see. So what we've got here, if I can find my little tools, here we go. All right, we're going to try and draw. Okay, there's our suitcase. Okay, it's square, close enough. All right. Got a cat here trying to get my attention, so I'll just try to ignore the cat. And let's see. So we've got a line, and let's make sure we got the right kind of line. That looks pretty good. We're going to have nothing on the end of it. We're going to make sure. Okay, good. So there we go. Our suitcase is being pulled along the floor here. So that means that we're going to be pulling up on the suitcase like this. Okay, that's our force. Okay, so let's see. I'll do this. So our force is equal to 45 newtons, right? F equals 45 newtons. Let's see how that comes out. Not too bad. Okay. So there's our force. Now, what's our angle? We've got an angle of 50 degrees. Okay? 50 degrees. All right. Don't you worry, you guys. In a couple of weeks, I'll be good at this thing. Right now, I'm a little bit of a novice. Oh well. Okay. All right. So we got a 50-degree angle there above the horizon, and we got 45 newtons, and we've got a distance going of 75 meters, right? Okay. I did find that double one there. Okay, so we are going to move this thing a distance S get out of my way. S equals how far? 75 meters. 75 meters. Okay. So, if we want to know the work done, we've got the force times the cosine of the angle times the distance, right? That would be the work. Let's put that down one more time. Remember, let's see if I can make that work here. Okay. Work equals force cosine theta times the distance. Okay, so in our case, work equals 45 cosine 50 times 75. Not too bad. Let me see if I can fix that. How about a regular paintbrush? Okay, that's supposed to be times. I don't like it. Let me do it again. Okay. Sorry, it's going to take me a while. Work equals 45 cosine 50. Okay, one more time. Work equals 45 cosine 50 times 75. This thing is going to drive me crazy. Okay. I know, it's really distracting. I'm really apologize to you guys because this is definitely taking away from your lesson. Just have a little patience and we'll get it. Work equals 45 cosine 50. Let's leave that part so far. Okay, good. Now, times 75. Okay. I know it's just frustrating for you, but just give me a chance. Okay, so one more time. I'm going to do it a little differently. I'm just going to say times 75. Better. All right. So there's where we have it. How about if I get rid of that one? I'll just cut it. Get rid of that one. Cut it. Get rid of that one. Get rid of that one. All right, so let's see. Now all we have to do is put that in our calculator, and let's see what we get. Turn on my calculator. You guys can do this along with me with your calculator, so go ahead and do it. 45 cosine 50 times, whoops, make sure you close parentheses on that cosine first, times 75. Okay, so I get work equals 3,257 joules. Okay, work is always in the unit of joules. Okay, let's see if we got the same thing. Now they got 2,170. 45 cosine 50 times 75. I'm going to pause this thing for a second. Okay, we're going again. So, it was the old case of my calculator was not in degree mode. So we'll go back, change that, and if we put our calculator in degree mode, which I'm sure all of you did, you get work equals 2170 joules. All right, cool. So you might want to pause this for a second and take notes of that if you haven't already, because I know it could take a little while to get your notes. Okay, what I'm going to do is I'm going to create a problem that you're going to do. So what I'm going to do is I'm going to create a problem, and you are going to write the problem. You're going to pause and work on the problem and then start again so that I can show you the problem. So let's see what happens if I try to draw a little picture here. Okay, so I'm going to make our standard push broom picture. Okay, and you are pushing that push broom. I'm not going to use any fancy things. I'm just going to draw, okay, because I don't want to waste too much time. So we've got 50 newtons pushing on this push broom, okay, and this is 60 degrees, one of our favorite angles, okay, and we are going to push this broom. Let's see, I'm going to just erase that for a second. We are going to push this broom a distance S equals 3 meters. Okay, so now what I want you to do is I want you to pause, and I'm going to just pause here first. I want you to pause, and I want you to solve this problem. And once you're done solving it, then I'll solve it, and we'll see if we got the same answer. Okay, so now let me try solving it. So obviously we're going to try to find the work. So let's see what we do. We know, maybe I'm going to just try for a while doing this without the recognition. Work equals, hold on a minute. Work equals force cosine theta times distance. Okay? So work equals 50 cosine 60 times 3. Let's see, work equals 50 times cosine of 60 is 0.5 times 3. Okay, that would be 50 times 25 is 25 times 3 should be 75 joules. Okay, is that what you got? Okay, you can pause that if you want to write it down, make sure you've got it, figure out if you've got something different, and let's move on to the next example in the book. Okay, so let me do a fresh page here, and I'm going to do in the book page 162, example number 2. Okay, so this is a bench press problem, right? This person is lifting a weight. Let's see, the weightlifter in figure 6.3a is bench pressing a barbell whose weight is 710 newtons. In part B of the figure, he raises the barbell a distance of 0.65 meters above his chest. In part C, he lowers it the same distance. The weight is raised and lowered at a constant velocity. Determine the work done on the barbell by the weightlifter during A, the lifting phase, and B, the lowering phase. Okay, so notice, I'm just tempted, I got to play with this toy a little bit. Okay, so notice what he said. Constant velocity. So what does that tell us? Constant velocity. That means, that implies equilibrium. Because there's no acceleration, okay? So, if we have constant velocity, then that means that we have equilibrium. Make you a pretty little picture here for your notes. Because there's no acceleration, so we have equilibrium. That means that if we have this barbell, okay, I just can't resist the temptation. I have to play with the toys. Okay, where's the pictures? Is that them? That's them. Okay, so the picture we want is a picture of a circle. I'm going to use this one. Okay, so here's our barbell. Okay, and I accidentally got that little thing there. I'm going to play with this again. Okay. All right, so let's see what we got here. We've got some forces. So we'll use that line, that looks fine. Let's use a little bit thicker, like this. Okay, so we've got, here's our mg. Okay, and then here is the force lifting up. So now, what we know is that because this is equilibrium, that means that mg is going down, and I'll just call it, oh my God, you gotta be kidding me. Let me try that again. That wasn't so hard. Let me try using this one. mg. Okay, and up here, we've got a force of the person lifting, right? So we know that mg, let's see, what are we told about this thing? 710 newtons, okay, equals 710 newtons. We're in equilibrium. These are the only vertical forces. So that means that this one also equals 710 newtons. Okay, now let's look at our question again. Okay, so what does it say? He's moving a distance of 0.65 meters. So we know that S equals 0.65 meters. Close enough. So now, what else do we have here? Question. Determine the work done on the barbell by the weightlifter during the lifting phase. So here's the thing. When the force is in the same direction as the motion, then we have positive work. So the work done by the lifter, so this is going to be A. The work done by the lifter in the lifting phase is going to be the force times the distance. Since they're in the exact same direction, we don't have to worry about the cosine, okay? So we basically got 710 times 0.65. That's going to be equal to the work. Okay, and let me get out my calculator. You guys can do the same thing. 710 times 0.65, 462, we'll call it. So W equals 462 joules. Is that what they got? Or 460, okay. So now, the work done during the lowering phase. So here's the thing. During the lowering phase, the motion is downward and the force is still upward, right? Even when this thing is going down, the weightlifter is still pushing up at 710 newtons because we're in equilibrium. Even though we're moving, the forces are balanced. There's no acceleration. So that means that now, if you want, we could say what we've got is negative 710 times 0.65 equals W. So now I'm going to risk moving this thing upward a little bit. Now our situation is W equals negative 462 joules. By the way, I'm going to redo this one because it made a T instead of a J. Okay. W equals 462 joules. I noticed that the textbook says 460, and they're actually right because it says 0.65, so there's only two significant digits, so we really can't have a 2 here. but you get the basic idea. All right, so now I should make up a problem for you to do. Okay, so let's see here. Here's my notes. Okay, here we go. I'm going to make a new page for our new example that you're going to do. And what I'm going to do is I'm going to do a little magic trick here. Okay, now I start recording again, and you see I drew the whole little problem here. So, plus I even brought in a little piece of artwork. Isn't that cool? So, here's the story. We've got a skydiver. Skydiver falls down 800 meters while the descent is being slowed by the parachute because of force of 500 newtons upward. Question is, what is the work done by the parachute on the skydiver? Okay, so why don't you pause it, and then you can go ahead and solve this problem, and then we'll do it together. Okay, go ahead. Okay, it shouldn't have been too hard. Let's see, let me get my, let me try using this thing again. Sorry, but I'm going to try it. Okay, so in this case, the work is going to be the force times the distance, but the force is in the opposite direction of the distance. So the work done by the parachute on the skydiver is negative work. The parachute is reducing the motion, it's slowing down. When you slow something down, you do negative work on it. When you speed something up, you do positive work on it. So in this case, the work is going to be equal to negative 500 multiplied by 800. So let's see, 8 times 5 is 40. So what we're going to have is that the work equals negative, I believe, 400,000 joules. See if it got that. Very nice. Okay, you see, because 500 times 800 is 400,000. We don't have to worry about the cosine because there's really no angle here. So that should be the end of my lesson. This would be a typical kind of lesson that you would do. You would read it at home. You'd follow along a little bit. You could back it up, redo it, go over it until you understand it well, and then you could come into class ready to do some problems. So in this case, you're already in class, and I will be there, and I will give you a couple of problems to do. Okay, thank you for your patience.